Hello, my name is Binush Kayum, and my optimization project was to optimize a proposed class schedule at WashU. This is a typical class schedule for the average WashU student. As you can see, there is a mix of lecture sessions and subsections for each course. On this schedule, there are some awkward breaks between classes. Some are an hour or even just half an hour long, which isn't long enough to make significant progress on things like homework or extracurricular activities. My project tries to eliminate these breaks so that a student's day is scheduled more efficiently. An optimized schedule opens up time for other interests a student might want to pursue outside the classroom. This screen should look familiar to anyone who has gone through the WashU registration process. Before every semester, every student runs their own optimization when they try to fit together all the courses they must take. Sometimes, like in general chemistry, the student must choose between lecture sections and numerous lab sections. My final project takes this process that every student does mentally and automates it, finding combinations of courses and subsections that the student might have missed. The following are the variables and constraints that go into my program. The variables include the course time slots and lab section time slots, which are when the courses and labs take place during the week. Also, the materials needed for the class are included. Each course was assigned a number 1 through 3, categorizing them based on how much materials, such as textbooks and notebooks, they would each need. This variable is related to how heavy a backpack a student would have for a given schedule. The constraints include the capacity and the number of available sections for both the courses and lab sections. A maximum backpack weight is an optional input by the users. The only needed input from the user is the course number for each course that they would like to take, plus one alternate so that the schedule can be optimized. Here are some screenshots of how the courses are input and how the results are displayed. The example shown here is for a 3-class schedule where 4 potential courses were input by the user. The program outputs the 3 classes for the optimal schedule. To the right in brackets is the total amount of time for a given week that would be considered downtime between classes. This example shows that there is no extra time between these 3 courses. The average backpack load is also given. In this case, it is a medium load. Other features of this program include a matrix with the downtime for each combination of classes. So for this example, the second row, which is an independent combination of courses, shows that in a week there is 3 hours of downtime for that set of classes. The fourth row shows that for that combination of courses, there is 6 hours in a week of downtime for that set of classes. The optimizer also lets the user know if the time slots for 2 courses overlap. In this example, Course 1 conflicts with Course 3. These 2 features provide further information for the students so that they can create the schedule that works the best for them.